Residency. It's primarily supported by the Privacy and Scaling Aspirations team, the Learning Foundation. And I'm Vivek. I was one of the organizers of this event. We're going to start with some just introductions on what this whole event was, what we've been working on, and also some introductions to the teams that are presenting today. So, we're going to go through a bunch of topics here. For people in the audience, just raise your hand if you're familiar with them as I go over them, just so we have like a sense of how much detail we should cover stuff. So all these were topics that we covered in the residency. Digital signatures was the main focus. Raise your hand if you're familiar with this, what a digital signature means or how it's used. Okay, cool. ZK proofs is another key thing. Most teams here have ZK somewhere in their stack. Raise your hand if you're familiar with that technology, how it works at even just like high level. TLS data, this is like less of a focus for these presentations. MPC and fully homomorphic encryption, are these topics that are familiar to people here? Less? Okay, noted. And then there's also a bunch of applications to Ethereum and general blockchain projects. Is that something that guests have familiarity with? Just raise your hand again. Okay, cool. That gives a rough sense of what people's familiarity is. Yeah, all of these were different cryptographic topics that people were using or playing with at the residency with their projects. And overall for this residency, there were a bunch of different goals. One just really core thing is almost all the teams here are highly international. They're built from folks in basically every different time zone you can think of. And so one big thing is literally just bringing these teams together and having really super focused work days for everyone to ship major parts of their projects. The other big thing about bringing all these teams together that are working on similar topics is trying to find synergies between different teams and also sharing learnings. A lot of these folks are working on really similar tech stacks, even using the same libraries. So just being able to tell each other little tips and tricks on how to do that. And the biggest thing is to ship something end-to-end complete that people can use and play with. We're gonna have our final demo day next week, which will be streamed live. We'll make sure to share that link with all of you folks. And at that point, every single team here will have a demo, but for this workshop, it'll just be a handful of teams presenting what they've done so far. So, the teams themselves. There's a bunch of different teams, which I'll briefly introduce just for people's information. I'll also have the teams kind of raise their hands. So, for the guests that have come today, if you're interested in learning more, you can sort of talk to them afterwards. So one major project here is ZK email. Can everyone on the ZK email team raise their hands? A lot of folks all over the place. ZK email is a really cool project. Emails all come with DKIM signatures. They are signed by the outcoming mail server. And so as a result, you can prove specific properties of emails verifiably, which is a really rare property, actually, when it comes to data on the internet. Most data is kind of just stuck in databases, and you can't really make verifiable claims about it. Another project is Anon Adar. Where's Yanis? Yanis is over there. Yanis and also Salil works on Anon Adar, but Salil just went back home sadly a few days ago. They're essentially taking RSA signatures in Indian identity cards and also doing the same thing where you're proving different properties of your citizenship, whether it be how old you are, state you're from, this sort of stuff. Appatest. We have Kaylee from Appatest. Sophian also works on Appatest. They also just left recently. Appatest is another cool project where you're going to see a recurring theme here. There's a signature in the app, or rather Apple will provide you a signature that an app is running sort of unmodified, so you can be sure that as an app developer, the way you built your app is actually being correctly done and it's not being hacked or misused. ZKPXP, another team that unfortunately mostly left, is basically, this is more of a blockchain-based project. So essentially, the setup here is being able to prove that, being able to onboard onto the blockchain by using existing payment platforms. I think they built out stuff for Venmo and Revolut and a couple of other things. But I think a lot of Japanese folks use PayPay. Something like this can also be integrated into their stack, where essentially you can pay someone on PayPay and actually on-ramp on-chain if they're a liquidity provider. I'm happy to talk more about this project if you're interested. The team is not present because they all slept. Some folks from Optimism Governance, Laura, you want to raise your hands? Working on applications of ZK to be able to prove statements about private data for Optimism badge holders. And also some folks from Gitcoin Passports. I don't know if Lucian is here. He just arrived yesterday. But someone working on the passports in there. So just a quick overview of all those teams. It was a really fast introduction, so feel free to like bump anybody here about what they're working on, and they'll be happy to tell you more. But the 3 teams presented today are MynaWallet, Proof of Passport, and Cursive. I won't go into too much detail about them because they're going to talk about their projects, but that's what we'll be hearing from today, and they'll all have demos that folks here can try. Here's just a collection of photos of the residency so far. We've been very lucky to be able to be in future works. Thank you to Chicago and the rest of the team. Incredible space. Also 24/7 if you're based in Osaka. Are you guys accepting new applicants? Chicago's right there. Can people apply to be a part of future works? Is it open now?
They are living in Japan.
Yeah.
So we can accept as a staff member. For staff member, we have the screening process. Yeah, please apply.
Nice. Come talk to Chicago. This space has been incredible for us and has helped facilitate some really focused working and jamming. And also we've just gotten to explore both Osaka and Kyoto. For a lot of folks here, it's their first time in Japan, so it's been really wonderful. Japan is a really dope country. A lot of cool stuff. So yeah. Just a quick review of the workshops. Myna, Proof, Passport, Cursive, we'll talk in order. At the end, we'll have some sort of live ID card demos for folks that have their passports. We can test actually making proofs with them. If you have your Myna card with you, you can actually use some of the MynaWallet stack. And the Cursive team will also give some demos using some NFC tools and folks. After that, we'll just sort of open the floor for both residents and guests. Feel free to just talk, discuss, ask questions, and just try to learn as much as you can, or get more materials. Cool, that's it from me. This is a link to the Signature Singularity website. For more information, it's just sigsing.com. So feel free to scan this, and thanks so much. I will now hand it off to the MynaWallet team.
So hello everyone, this is Hiro and Nico. Today we are going to introduce our MynaWallet. But first, we are going to demo in Japanese. So ここから日本語で話します。時々ニコがトランスレートしてくれます。
Translate あんまり、I want the voice translate. Sec, please understand Japanese.
まず、今回のデモは、you can download our demo from this link. So if you are interested in trial demo, please follow the information on this QR code.
Yeah, so for the demo applications, you don't have to have a Myna card. You can just use our software keys. Even the people who don't live in Japan, you guys can try our demo application. Alright.
ではここから日本語で始めさせていただきます。私たち A42X の立花と、ニコです。あと後ろの方に、進藤、さんがいて、今3人でMynaWalletの開発をしています。で、MynaWalletを一言で言うと、全ての人が今すぐに安心して使えるデジタルウォレットとして、作っています。具体的に言うと、日本に居住している、皆さんのお持ちのマイナンバーカードそのものを、ウォレットにするというようなプロダクトになっています。ウォレットの事前なアプリのインストールだったりとかセットアップは一切不要で、カードをタッチするというだけでデジタル資産の送受信や、あるいはその特定の資産を持っているということを、証明することができます。でおよそ約、1億人持っているマイナンバーカードを活用することで、小さな子供からお年寄りまで、全ての人が、Web3 だったりブロックチェーンという、難しいことを理解せずにそれらのサービスを享受できるという世界を目指しています。で、今我々が持っているマイナウォレットペーター版というのを今現在、公開しています。ここではマイナンバーカードの中にある 公開鍵をそのままブロックチェーン上に公開しています。で、マイナンバーカードの署名によってスマートコントラクトのウォレットが動くようになっています。さらにこのマイナンバーカードの中にある RSA の署名だけではなくて、パスキーによる署名とも合わせていわゆる二重の署名を検証することによってより安全にウォレット内の資産を守るといったような機能を作っています。ちょっとここまでだと喋ってばっかりなので動画をお見せしようと思います。まずマイナーウォレットをスタートすると、マイナンバーカードのピンコードを入力します。で、マイナンバーカードを、持っているマイナンバーカードを実際にタップをすることで、署名を行います。そうするとマイナンバーカードの中にある、利用者用証明書から1対1に紐付くウォレットアドレスというのが導出することができます。こうすることによってカードと1対1でウォレットが紐づくので、例えば何でしょうね、例えばウォレットをそもそも例えば資産を受け取ったりとか、あるいは何か、NFT を受け取ったりというときに、ウォレットをそもそもインストールする必要なく、カードだけを持ち上げていれば、もう、そこに対してウォレットと1対1で紐づくので、何かしら資産を受けたりとか受け取ったりということができるようになってきます。で、ごめんなさい、ちょっと順番前後するんですけど、例えば、こちらのちょっとフリーバージョンのデモなんですけど、カード自体がもうウォレットになっているので、例えば NFT を配りたいってなったときに、そもそもカードをタップすれば、そこから1対1で紐づくウォレットアドレスっていうのが導出されるので、例えば NFT を配りたいスタンプラインみたいなことをやってる企業ってたくさんあると思うんですけど、そういったときには、そもそもウォレットインストールしてもらう必要がありません。カードだけを持ってきてください。カードをタップすれば、もうそれと1対1で紐づくウォレットっていうところに実際に NFT を配布するということが可能になります。で、こちらもう1個デモなんですけど、実際にじゃあトランザクションを送るときに、今これはトランザクションを送るデモです。今0.01イーサを、0.001イーサを特定のアドレスに送るんですけれども、その時にもちろんマイナンバーカードの署名を行います。マイナンバーカードの4桁のピンコードを入力して、そこに実際にカードをかざして署名をする。だからこのピンコードを入力するだけじゃなくて、フェイス ID、いわゆるパスキーを、さらに検証するようにしていて、そうすることで、マイナンバーカードだけのちょっと署名だと怖いなっていう人であっても、パスキーを追加して、パスキーの署名で、安全に資産を持ったりすることができるような機能になっています。はいで、ここで課題なんですけれども、現状のマイナウォレットは、マイナンバーカードの中に入っているパブリックキーをブロックチェーン上に公開する必要があります。そうすると、いわゆるマイナンバーカードの利用者用証明書をトラックできる人たちが、誰がどういう資産を持っているか、誰のウォレットアドレスなのかっていうのをトラックしてしまうことができます。そこが現在の課題になっていて、今回、ニコ君がそれを解決する、ソリューションを、発表してくださいます。それでは、ニコ君どうぞ。
はい、ありがとうございます。このハッカーハウスというか、このレジデンシーで、ちょっとハッカソン的に作っていたのが、マイナウォレット ZKP っていう ZKP を活用したバージョンのマイナウォレットになります。でマイナウォレット ZKP では、マイナンバーカード内の公開鍵は取得したままで止まりません。で、取得はするんですけれども、ゼロ知識証明を活用することにより、署名検証を可能にしています。またさっきの今までのベータ版だと、マイナンバーカードとパスキーのダブル署名になっていて、なんていうかパスキーの利点というか、パスキーの使いやすさというかっていうのをあまり活かせていないような感じだったので、パスキーのみによるか、ゼロ知識証明を使った署名検証をするかっていう両方どちらか片方だけを使ってトランザクションを発行できるようなものを作ってみました。ということで、デモをしたいと思います。で今から、さっきも最初に話したんですけど、今から見てるデモですね、こちらのあそこの QR コードを読んでもらうと、HackMD のページに飛ぶんですけど、その HackMD のページに、テストフライトに追加してほしいApple のアカウントだったりだとか、ウォレットを作った後の口座を確認するためのフォーセットを送るためのアドレスとかをリストしといてもらえると、勝手に追加して送っていくので、ぜひQR コードからどんどん追加していってください。はい、じゃあどうぞ僕の画面を。 スライド見せつつ、僕の画面見せることできますか？難しい。はい、ありがとうございます。そしたら、これが今のマイナウォレットベータですね。ZKP バージョンのマイナウォレットベータになってます。で、このデバッグモードっていうところからマイナカードエミュレーターっていうのがあるので、ここをオンにしてもらえると、クリエイトマイナカードっていうので、ダミーのマイナンバーカードを生成します。でも一応本当に使われているか確認してもらいたくて、もう一回開くとここに、ちゃんとモデローズっていうのができてて、ちゃんと使われてるんだなっていうのが確認できると思います。で、作ったら、スタートしていきます。で、これ普段のマイナンバーカードと同じようにピンコードを入力するんですけど、このピンコードも適当な値で問題ないです。これ僕の場合だと1234を入力して、これもこの前までのアプリの名残ですね。単にスキャンを押すと勝手にアプリのソフトウェアの中のマイナンバーカードを読み取ってくれます。そうするとこのように、マイナウォレットができました。なのでちょっとこのアドレスを僕一旦そのアドレスを追加します。なので僕はこの写真を読み取って FMD ですね。はい、すごいいっぱい追加してもらってる。でここに書き込みで、すみません、ちょっと書き込めないので、これちょっと一回外して、表示できるか。ちょっと今、ごめんなさい、ちょっと機器の、ミスがあるんですけども、今、僕のウォレットを生成したので、このウォレットにイーサリアムを送ってもらうように待ってます。で、このウォレットで ZKP を使うっていうんですが、そもそもまず ZKP とは何かということで、What is ZKP ということで、ZKP とは何かというと、ある値を秘密にしつつ、その秘密の値と他の公開している値の関係を証明する技術です。で、黒いのの裏には本当は24という値が入っているんですけども、24という値を公開することなく、隣にある20という値との値の関係みたいなことを、その黒の値を公開することなく、この関係が正しいんだよということを証明することができます。で、後でちょっとデモで見せるんですけど、この証明を生成するための計算が大変という難点があって、ちょっと僕のスマホがつながったなと言いたいので、ヒロのスマホがつながったんですけど、ヒロのスマホで、その証明の計算が大変ということを見てたいと思います。で、このトランスファーっていうところを押すと、イーサリアムを送れるんですけど、2つ方法があります。1つがナリファイヤーっていうのと、もう1つがパスキーっていう方法で、こちらのナリファイヤーっていう方を押すと、ZKP を計算して、ゼロ知識証明でトランザクションを送ることができます。例えば、0.01差を送ってみる。トランスファーを押すと、今この裏でこの iPhone がゼロ知識証明の計算を行います。今行ってます。はい。今、ジェネレーティンググループで、今裏で計算を行っています。で、これ非常に計算が重たいです。これ30秒から40秒ぐらいでかかってしまうので、本当に POC みたいな感じになってしまいますね。で、ZKP とここではナリファイヤーという値を使って、トランザクションの検証を行います。で、ナリファイヤーという値は何かというと、ナリファイヤーっていう真ん中に文字列があると思うんですけど、ある特定、プルーフの証明が終わりましたね。ヒロのスマホだと30秒で1つのトランザクションを送るのに30秒かかります。はい。で、ナリファイヤーという値何かっていうと、 ナリファイヤーっていうその特定の文字列に対して、その署名ですね、署名を与えて、そのハッシュ値のことをナリファイヤーと呼んでいます。で、ゼロ知識証明のサーキットの中では、こんな風な関係をこう証明しているんですけれども、はい、これがナリファイヤーですね。ナリファイヤーは、ナリファイヤー、ハッシュドストリングってもともとそのナリファイヤーという文字列、公開されている文字列に対する文字列ですね。でその文字列に対して、署名を行います。でその署名のハッシュ値がナリファイヤーになります。で、ゼロ知識証明サーキットの中では、ナリファイヤーとその公開されている文字列と、ハッシュド UOP が今から送りたいトランザクションの情報ですね。っていうのを公開しつつ、これら3つの値っていうのは秘密にして、シャー256っていう計算だったりだとか、RSA の署名検証の計算だったりとかをして、これらの赤い公開されている値と、紫色の秘密の値の関係を証明します。で、ナリファイヤーが公開されているので、もちろんそのナリファイヤーと紐づくナルシグは正しいし、このナルシグと、もともとナリファイヤーという文字列は RSA の署名検証で、公開鍵ですね。マイナンバーカードの公開鍵が正しいことが証明できるし、そのマイナンバーカードの公開鍵を使って、このハッシュド UOP、僕の繰り返しトランザクションに対する、RSA の署名検証を行うことで、この僕の送りたいトランザクションっていうのは、本当にその僕がちゃんと作ったものなんだっていうことをゼロ知識証明サーキットの中で、検証することができます。でさらにその上にこのモデル図を公開することがないので、モデル図のリストを持っている人であったとしても、このウォレットの持ち主っていうのは誰かということは分かることはできません。以上が今回作ったものですね。で、さらに僕たち今、パスキーも今イネーブルしていて、このようにパスキーからの、トランザクション、すごいいっぱい作ってるんですけど、はい、パスキーからのトランザクションを送ることができます。なので、マイナンバーカードを使って、マイナンバーカードを使いつつ、プライバシーを担保するっていう署名の方法と、パスキーを使って非常に高い UX の、ウォレットを今作れているっていうような感じですね。で、A42X として、次の動きは、次期マイナンバーカードの署名アルゴリズムへの対応と、今30秒ぐらいかかったそのゼロ知識証明の生成なんですけれども、これをもっと早くしないと使い物にならないということで早くしたい。ただマイナンバーカードってそのただ単にその鍵の生成器としてじゃなくて、他にもいろんな僕たちのアイデンティティっていうのが入っているので、そういったアイデンティティを活用する。また他のアイデンティティと統合していくみたいなことをやっていきたいなというふうに考えています。以上が我々のプレゼンになります。どうもありがとうございました。はい、どうぞ。
署名の部分、コントラクトレ
はい。
コントラクトレ
そうですね。はい。
Can you repeat the question?
Repeat in English or?
English.
For the video.
Sure. It's like, so if you ask me like, how, it's like, to verify the signatures, do we use account abstraction or not? And then I say yes. I use account abstraction. Yeah. 他に質問はありますか？はい。
マイナンバーからマイナウォレットに行ったと思うんですけど、
はい、
その時にやってるのは、いくつかデータ転送してると思うんですけど、その認証に必要なデータだけそれとも個人情報のデータも転送してる。
そうですね。すべての情報を転送しています。
Yeah, so he's asking about the video communication card and apps. So in MynaWallet, there are 4 basic information like name, birthday, or the physical address or something. And then there are 2 other MynaWallet cards. there are two certificates, 2つの証明書がマイナンバーカードの中にあります。And one certificate has these kind of full information like name, physical address or something. 一つの証明書には名前とかがあって、the other certificate doesn't have such information. もう一つの方は全くそういった情報を含んでいません。
取得しているのはどっちのことですか？
取得しているのは、取得という言い方があれなんですけれども、基本的には利用者用証明書っていう、個人情報を含まない、利用者証明書を活用しています。So, we are currently using the certificates that doesn't have the personal information. But, もし、今後その基本用情報だったりとかを、例えば、政府が提供している DKYC API 問い合わせたい場合っていう時だったりとかは、そういう場合は、その基本用情報が含まれた証明書を取得することが必要になっています。はい。
このシステムは実際に L2 とかで使うと、トランザクション費いくらぐらいするんですか？
現段階だと、
トランザクション費は1トランザクションで、まあ、高い時で40円とかですね。
400系ガスぐらいですね。なので、例えばベースとか安いガス代のところだと、普通に使えるんですけれども、ちょっとトランザクション費が高いところだと、ベースの費が高いところだと、なかなかまあ、これはアカウントアブストラクション全体に言えることなんですけど、そうですね。はい。
でもう一つ、そのスマートコントラクトのアカウントを、パブリッシュするとき、それいくらぐらいですか？
パブリッシュをするときに使うのは、
一人一人パブリッシュする必要ありますか？
Yes。
一人一人パブリッシュをする必要があるんですけども、まあ、アカウントのデプロイに関して言うと、まあ、ペイマスターを使って我々がカバーをするっていうことはもちろんできる。で、まあ、今のところそのペイマスターでカバーすることを考えているので、クリエイターアカウントに関してはそこまで詳しいガスフィーっていうのは取ってないんですけども、まあ、トランザクションに関して言うと、今言ったヌリファイヤーとかになると、まあ、400K、もっといくと 600K とかになってしまうときもありますね、機械のトランザクションで。ただまあ、それからですね。はい。他に。じゃあ、終わります。ありがとうございました。
Thank you very much.
So thank you so much, MynaWallet, for this presentation. Florent is setting up the slides.
Unfortunately, we won't be able to do the talk in Japanese, but if you have any questions, you can ask them at the end, and maybe we can have some help from someone that's more fluent than us. All right.
Okay, let's go. So, hello everyone, nice to meet you. First, I would like to say thank you for the opportunity to talk about the project today. My name is Rémi, and with Florent, we are going to talk to you about ZK and identities. Because we truly think that those subjects will be one of the big questions in the next few years. I don't know if some of you have seen the demo of the latest GPT just a few days ago, which is kind of crazy, and now AI can pass phone call, which is really cool, but on the other hand, it means that it could literally call your grandma with your own voice and just scam her, which is not great. So that's why many applications will need to verify the identity of their users. And actually, it's quite hard. like they are stuck between traditional KYC solutions and, on the other hand, other technologies such as WorldCoin, which need to spread their infrastructure widely. Fortunately for us, there is already the International Civilization Organization that builds a great tool on which we can piggyback on, which is the electronic passport. These documents that you may have embedded a chip with inside a bunch of data about you, which is signed by the issuer country. So if you got this logo over your passport, this means that you actually got an electronic one. And this is the case for the Japanese one. Yeah, so I think that you may already understood where we are going to. So please let me introduce you Proof of Passports, which is a mobile application which lets you scan your passports and generate some ZK proof on top of it. So why ZK and passports? Because by combining those two technologies, we can answer to several issues related to identity. The first one is the sybil resistance. How to prove that it's a human who's behind an action, like a tweet or a vote, or maybe a phone call too, as we said before, which is really important. The second one is the selective disclosure. You may want to reveal something really precise about yourself without revealing anything else. And you can achieve this using ZK. So maybe you want to prove that you are over 18 or that you have a specific nationality, but without revealing anything else. And the last one, the two last ones are due to the fact that some passports actually host a chip who can sign data, which allows you to sign transaction or achieve wallet recovery. So maybe we can just take a look at the demo so you will have a better idea of the current flow of the application. So the first step is just to take your phone and scan your passports with the camera and then with the NFC chip. Note that at this point everything is achieved locally, so there will be no personal information shared with external application. Next step, just select the application you want to generate the ZK proof for. In our case, we will select the Subon token. And finally, you can select some specific disclosure that you may want to disclose. And in the case of the Subon token, you can also enter your ENS or your HUM address. And that's it. You're ready to generate the proof and to mint the Subon token. So you can see that in the case of the Subon token, I've shown that I'm older than 18 without even revealing my age or my birth date.
Okay, so now you may be asking yourself, how is it possible to do that? Like, how does it work? So basically the ICAO, which is the International Organization of Aviation, that like does all the specs of everything that's like related to airports, for instance, they have a really precise spec, and if you look at it, it's like 300 pages, it's super complex, like lots of different padding formats and like ways to hash things together, but basically what happens actually is quite simple if like we get it down to the basic level. Basically, you have a bunch of data groups. So the first one is the MRZ, and the MRZ is the thing that's actually on the photo page on the passport here. And so it has like most of the information that's relevant about the person, like the country of origin, the name, there's like the passport number, which does not disclose like much, but there's like the date of birth, the date of expiry, which is like all like interesting things. And then you have like also the photo and a bunch of other data groups that are like less important. They are all hashed, then concatenated, all hashed together, and then they are signed with the private key of the government. And so those private keys often rotate for like security reasons. And what's really nice and what actually like makes all this possible is that those, like the public keys corresponding to those private keys, actually like available on the internet in like huge registries because like the companies that do the machines at the airports that need to verify the passports, they need those public keys to be able to make sure that the passports are real. So what's nice about this whole flow is that we can check all of it in a circuit. And if you know a bit about zero knowledge, you know what we can do with it. We can basically prove that we know some like valid input to a function at a very high level without having to disclose all of the inputs. And so what we are going to be able to do now is to prove that we have a valid passport without having to disclose all of our private information to the person that we want to prove it to. And one nice way of doing that, we weren't doing that at the beginning, but now we're going to do it in this manner. So here we have like a basic like idea of all of the data that's inside. Most of this is quite useless, but some of those information, especially like nationality and date of birth, are quite useful. So the way we used to do it is just with one big circuit, but there's multiple advantages of doing it in two steps. First, registration and then action. So basically during the registration, you're proving that you have a valid passport and you're creating this commitment in this tree. This is a design created by Semaphore, it's another PSC project, and basically in Semaphore, you can have like an admin creating a group and letting people prove that they have identities in the group. But in our case, we don't want an administrator to decide. We want like only the verifier circuit to be the only authority of who has a valid passport. So you like put your data in this like commitment, and it's hashed with a secret. And this secret, of course, is very important because with the hash function, it's what is going to the hash function anonymizes you first, and the secret is going to make you, it's going to like empower you to then do actions and like selectively reveal like things about yourself. And this is what you can do. So an action can be like voting in like a shadow election in a country. It can be like creating an account on like an adult website that wants to check that you are above 18. It can be like buying alcohol or something if you have to be like above 21. Or it can just be like do a tweet or like anything that requires you to be a human. Maybe one day like have a call with your grandma and she can see a little check mark and know that you are really who you claim to be. So for instance, in this example, like Satoshi Nakamoto, I guess, can like prove that he's Japanese, but like hide all of other data that's sensitive. So those are basically the two steps. This is what we like mostly work on this month, and it's been quite nice. So what country can support proof of passport? So what's nice now is that most of the countries emit only electronic passports, which is nice. If you have a like very old passport, maybe it's not like it does not have the chip in. If you are like from India and a bunch of other countries, you definitely don't have it now. But it's like getting there, and so we can support more and more countries. But the tricky thing is that the specs are really like free and like vague, and so there's a bunch of different signature algorithms that the countries use. And this is making things quite tricky for us, obviously, because if we want like universal support, we want to support as many of them as possible. So the one we currently support is the first one, and like the three like next ones that are the most used are work in progress. Like we have a repo. If you already know a bit about like Circom and ZK, or if you want to know to like learn about it, I think it's a really nice like exercise to take all of those like already existing like primitives and assemble them to like those verification circuits. Not that hard actually. Now that like the whole flow is made so that it's easy to integrate. And yeah, you can see like there's a bunch of countries that just like Germany that just used like multiple of them for some reason. They just decided like at one point to switch. Yeah, so if you're Japanese, like the current app might not work with your passports, but I think like you'll see at the end there's a demo where you can still download it, and probably in a week or two you'll have a notification saying like we added support, and then you can like try it with your own passports. And another nice thing we've been working on this month is that like we don't want just people to be able to mint an SVT, obviously. We want like any application to be able to integrate that easily. And so now we have like a really simple format in which you can just like copy paste the file, like put everything that's related to your app. There's a bunch of like functions that you can fill saying like where does the proof go, like the user is redirected to the app, and then like you can send the proof to your server. You can like choose what the user can disclose, like as something may be optional, something can be required, and then like if you do this PR, we can just merge it, and like now you can check all of this for your users.
Yes, unfortunately there is also some drawbacks due to how the passports work today. The first one is that there is no way to know if a passport has been borrowed or stolen. Also, countries own the private keys, so they can sign new passports. And finally, maybe some of you today have a dual citizenship, and if it's the case, you may actually own more than one passport. Yeah, so also we would like to tell you that this project is fully open source from the mobile app to the circuits, so you can commit really easily to the project. Also, we would like to say thanks to PSC and the Atrium Foundation for the grants. So yes, let's build proof of passport together. It's quite easy to, as I said before, to commit to the repo. Just scan this QR code. It's a link to the open beta on iOS. Maybe it will work with your passport, maybe not. If it don't, just let us know. We could integrate those primitives together.
And especially if you have like passports from other countries than Japan, like any country, you can just go and see us at the end. We'll have like a little table. We can try to scan yours, and like could be also useful because we want to have like a better idea of which country use which data algorithm, and it's not that easy to like know because basically only the companies that do the material, like the machines that check that, know this data and they don't tell it to anybody. So that would be like really helpful. So I think now something I should try to do is like show you the actual app. Maybe you can like ask for a question first so that I like.
Yeah. Does somebody has any question? It can be English question or Japanese question.
Okay, so here you can see the current version of the app. So basically the first thing you have to do is not scan the NFC chip, it's to scan the first page of your passport, because the MRZ, this part, has some information that's like the password to the chip. And the reason for that is that if there was no such password, like people could just like scan the passport without asking the person, without even like having it open, like by like touching the pocket of someone or something. So this is why it's nice to like have this first, and then you do like scan with NFC, and you just put it on it. So here you can see like the data being read. Digi2 is the photo, and it's why it takes longer because there's whole photo being transmitted. And now you have like the applications, and we can just, this is like my actual photo for my passport. I can just like put my DNS here. It's looking on the chain, we found my address, and now I can like just, for instance, put it in French, nothing else, generate the CK proof. So we worked a lot on client-side proving with teams like WoPro, Vivek is here for WoPro, Osaka is coming soon. And this is like a nice little illustration of the ZK proof that's been created. And now I can click on mint, my Solon token, it's going to send the transaction. And once it's done, it's going to like, just like send it to my address. Takes a bit of time because it's Sepolia. But yeah, I mean, yeah. Does anybody have any question?
Wait, so you made the secure proof and it sends an NFT. Or
Yes.
what's it sending to the wallet?
What's the
Because
question?
you mentioned that you put your ENS,
Yes.
and then I'm guessing that something is, or like why did you input your ENS?
So the reason I put my ENS is so that the SBT, which is basically an NFT, it's just non-transferable, is sent to my address. And actually, the reason, like, there's an important fact here is that the address I'm going to like send the SBT to, which is mine, is actually committed in the proof. It's not just separate. And the reason for that is that if it was just separate, somebody could like see my proof before it's actually included on the blockchain. So like see it like before it's included in the mempool, which is like where transactions go before, and they could like try to front run it and use the same proof to mint it to another address, which would be like stealing my proof. And the way we prevent that is by committing to the address inside the proof, so that like you cannot change anything about the proof once it's committed. So even if somebody like takes your proof and mints the SVT, just going to mint it to your own address because you already put your address on it. Yes.
Thank you. So maybe I misheard this description. My question is, how do you verify the rotation of the public key by the government? Because you said the public key is often rotated for security reasons.
Yes.
Do you want to repeat in Japanese?
Yes. 質問としては、政府の署名に使う公開書きが頻繁にセキュリティの理由で更新されているんですけど、その公開書きが本当にその最新の政府のものかっていうのをどうやって検証するのかっていうところを質問しました。
So what's nice about those like registries, especially the one that the ACIO keeps, which is the largest one, is that they include all of the keys, even the previous one that were like rotated. So you have like the whole history, and you also have the validity date of the certificate, so you know like if a passport has been signed during the right like time with this key. This also makes things tricky because now there's a lot of keys. So there's 50,000 keys in the Merkle tree that we support, and basically the only way you can check it is not by like checking each of them individually in the circuit. It's like by doing this huge Merkle tree, if like people are familiar with this structure, and then like the person can prove that the key that signed a passport is part of this Merkle tree without disclosing which key. So you don't have to say like it's this key from the Japanese government that signed my passport, because then you leak the fact that you are Japanese. You just have to say like it's one of those keys that are part of like all of the like valid keys.
Thank you for your answer.
Any other question? Yes, Andrew.
Yeah, so when I recently flew into Europe, they now have these gates where you don't like talk to anyone. You just go like put your passport like down on a reader and it just lets you through the gate. Do you know if they do anything with signatures in those gates, or is it just like reading the?
Yeah, they copied us. Yeah, so those new gates, they actually check the signature in the passports, and like they also see your face and everything. There's a bunch of applications that are starting to put that into production. For instance, now if you go on LinkedIn, you will have like an option, most people, to actually like check that you're like to basically have a check mark next to your name on LinkedIn, because obviously they have a lot of spam. It's like really important for us for them to be sure that people are real. And you can like go on this website and scan your passport just like we do, and validate your identity on LinkedIn. The key difference is that with what they do, you send all of your data to them, and with what we do, everything stays client-side. So only the proof leaves. All of your passport data will never like be leaked to a third party.
Are the SVTs, like, do they have anything in common? Like, if I inputted a list of all of our addresses and like 80% of us minted the SVT, would I be able to tell which addresses have that type of SVT minted to know? Like,
yeah.
if I only wanted to know from this pool of a gazillion addresses, how many of them have verified that they have the password?
Yeah, you can do that very easily on the contract of the SBT. You can just like check who has one, and you can also do that in batch. So it's easy to visualize. You can also go on OpenSea, which is quite nice and shows all of the SBTs and just show like who in the collection has one. But I think the most like the SBT is kind of to showcase the thing. I think the most like important use cases are probably off-chain verification, like with the server, like proving to another party, but on-chain is like maybe for DeFi things, or for airdrops. But yeah, it's only one of the possibilities. All right, another question? Nice, let's wrap it up then.
Thank you.
And I summon the Cursive team to come.
Hello. Okay, my name is Andrew. I work with Callie, and Rachel's over there, and Vivek over there. We work on Cursive. So Cursive is building applications of digital signatures and advanced cryptography to enable data ownership. And today we're going to be talking about something quite similar. So how we can use cryptography for verifiable ownership of personal data. Now, this is quite a big question. How do we take user-owned data and make it private, make it personal, but at the same time allow it to be verifiable? So to narrow this down a bit, I'm going to focus on one specific area of this, which is how we can verifiably prove in-person interactions. So I meet someone in real life, I've interacted with this person. How can we take this fact, how can we take this piece of data and make it verifiable, make it user-owned? And up until today, our answer at Cursive has been to use two different technologies, namely NFC and digital signatures. So these technologies pair really well together in enabling data ownership and verifiability, and we'll talk a little bit about each of these and why they're important. So first off is NFC. A lot of you are probably familiar with NFC today. So all of these things in this picture use NFC. NFC stands for Near Field Communication. It basically operates over radio, and it allows two devices to talk to each other. And so your Myna card uses NFC when you tap it. Your Suica card or Passmo or whatever you use to get on the train, that also uses NFC. Credit cards, hotel cards, even some car keys, these all operate over NFC. And NFC is this like wonderful communication modality that allows two devices to talk in close range. So why do we care about NFC? Like, why is NFC even cool to begin with? Well, I think the most interesting thing about NFC to me is that it actually has to happen in person. So every single NFC interaction requires two people, two devices to be near each other. That's just the property of NFC. And so this allows us to take an interaction and actually like verify that, hey, something happened in real life. Because that's what the communication requirement is for that technology. And so all of a sudden we get really meaningful attestations because, hey, when I'm in real life with someone else, like, and we have an interaction together, that represents something more meaningful. Either we've attended an event in person, or we've like shared an experience in person. But because that actually happened in person, we know that that's something significant. That's an important piece of data that gets registered by NFC. And on the other hand, like NFC is pretty intuitive. I think at this point, a lot of people have already begun to use NFC for many different years. So all of your Apple Pay interactions, when you go and you pay for groceries or something, when you go take the train, all of this is done over NFC. And so at this point, like a lot of people are really used to NFC, and so it's just a good way to record these interactions because it allows us to do all of this in a modality that is more familiar to people. But at the same time, like NFC also has its drawbacks, namely that it is just strictly a communication modality. So NFC doesn't provide any guarantees on the verifiability of data. It just allows us to transport data from point A to point B in a close range mode. And if we want verifiability, then this is where signatures comes in. Signatures is the cryptographic counterpart to NFC that actually allows us to take an interaction that is in person and make it verifiable, make it provable, and make it have significance. So, give a brief overview of signatures. Signatures have been like the focus of this residency, and they've also been in all the projects that I've already talked. So, proof of passport is verifying signatures. MynaCard is also verifying signatures generated from the card, and so signatures are everywhere. I'll go a little more into like signatures and what they are if you're not familiar. So basically at a high level, signatures are providing authenticity. They allow us to take a piece of data and say, hey, this piece of data was created, was produced, originated from a specific person or a specific entity. And this guarantee is really powerful for us in our use case because it allows us to prove that interactions were performed by a specific person. So specifically how this works is you generate a public and a private key pair. So this is just a bunch of bits, a representation of some mathematical object. These public and private key pairs are linked, and I have like my private key, I keep that secret, I don't share that with anyone, but my public key, I will blast out into the world. I will say, hey, my name is Andrew, this is my public key, like anyone can go and look up this public key, and they can use that to verify that certain things were produced by me. There's two parts of signatures. One is that you can sign stuff, so you can take a piece of data, like I have a message that I want to send, and I can feed this data into some computational algorithm, and that signs the data. That generates a signature that represents cryptographic proof that, hey, this data was produced by me. And anyone else can go take my public key, take the signature that I just generated, and they can verify it. And this is universal, and anyone can do this very cheaply on their own device. And real quick, like, why do we care about signatures in the first place? There are many different ways to do verifiability. Why are signatures so interesting? First off, they're like really small and portable. So ECDSA signatures are around like 64 bytes. That's the specific signature scheme we use, and you can just easily send it with the data that you are signing. And so it's efficient, it's very lightweight. It's also context independent. What I mean by this is that every single device knows how to verify a signature. So like you can think an alternative to signatures might be, hey, like let's just like trust Apple. Whatever Apple says is the source of truth for a piece of data, like we'll just trust Apple. And that's fine, but like then you need like proprietary access to Apple. Like they can like, you know, have permissions on their data. They can have permissions on how you verify their data. And signatures are a way to do that, to get all the properties of verifiability without trusting anybody. And so any device can verify a signature. Any device can verify a signature very quickly. These signatures can be verified offline. And overall, they're a great way to communicate this property of authenticity. Finally, signatures are composable because they're like the basic building block of cryptography. Anyone can build stuff on top of them. Anyone can use signatures and their properties to, say, like create smart contracts that depend on authenticity. And so they just serve as like a great foundational layer for building other things on top. That's why we're so interested in signatures. Cool. Okay, so now we're going to talk about some of the things that we at Cursive, we've actually built with NFC and signatures. So this is going over some of the activations we've done in the past. And we'll talk about just some of the things that NFC and signatures combined actually enable. So a long time ago, in Zuzulu, over a year ago, Cursive built out proof of participation with a project called ZooStamps. And the idea here is that you would have these different stamps all over Zuzulu, and each stamp would represent a specific thing. So this gym stamp here would represent the fact that you went to the gym. How does this actually work? Well, like there was an NFC card that was like literally placed at the gym. And so this card would just be at the gym, and since every card has like a unique key pair associated with it, you would have to like go to the gym and actually tap that card in order to get a signature that proved you went to the gym. So these interactions now all become verifiable, and you can see all these different things. There's like one for running, celebrating sunrise, like attending a cold plunge, and you can take these signatures from all these events, and you were able to like store them in your own identity wallet, which is like ZooPass. Next up, talking a little about DevConnect now, which was last year in November. This experience was called Jamojis. It was something sort of similar, but at the same time, like quite different. In this experience, we gave people NFC cards. So 200 people got NFC cards, and each card was represented by an emoji. And you could go around and you could tap other people's cards, and this would represent the fact that you actually met that person. So if you had a card and I would tap you, I would get like an emoji from your card, which was like your special emoji. But really what was happening was I would get a signature from you that represented this verifiable interaction. And at the same time, we also built some quests around it. And so for example here, like if you met Vivek and I, you could collect a signature from each of us, and proving that you had this signature allowed you to go attend a secret party that we hosted, which never ended up happening. Finally, or not finally, but at Eat Denver this year, we built something that was more centered around loyalty and engagement. So these badges were equipped with NFC cards. This was a much larger scale activation. So pretty much all like 15,000 badges at Eat Denver were given NFC chips, and you could go around and pretty much tap anyone's NFC chip at Eat Denver. And in addition to that, there were also like NFC chips hidden around the venue at workshops and at different talks, and you could check into those as well. And what this allowed was proving that you actually engaged with the event, proving that you actually participated and had fun at the event. There was a merch store associated with this, so by tapping a bunch of people's signatures, by proving your interactions, by proving you attended talks and workshops, you could actually go redeem items from the store. Now, finally, this was the last thing we did, which was at ZK Summit, some cryptography conference this past April in Athens. And this was about building empowered social experiences with NFC. And so this one I'll go more into. We'll actually go into the app, and then later on we'll all be able to demo some version of the app that we built for this residency. So setup here is something similar, where every attendee got a badge with an NFC card inside. In addition, we set up badges for the talks and the workshops at the conference. And you could walk around, you could tap other people's cards, and you would get their contact information as well as the signature representing that interaction. You could also go check into certain talks or workshops, and if you went to a talk, you would tap into the room before you actually attended the talk, and you would get a signature from that talk, proving the fact that you actually did indeed go into that talk. So let's actually dive into this experience and talk a little more about what this experience actually felt like and what interacting with NFC and interacting with cryptography actually does feel like in practice. So here, the setup is that you tap cards and you collect signatures, but at the same time, we're able to group different signatures based on where they came from. So we can define, hey, all of these speakers, these are their public keys. Remember I talked about how every signature is associated with a public key, and every person has a public key as well. So by collecting signatures, I can prove that, hey, I actually met these people, and all these people are associated with this speaker tag. So all these speakers gave me signatures, and therefore I can prove that I met 5 speakers, for example. So this is what the app looked like. This is what you could actually do with the app. So I would tap someone's card and I would get a signature, and that would also share contact information as well. I could attend talks, check into workshops, do all of that, and then I could also generate a bunch of proofs about the things that I did. And this collection of signatures serves as a nice history of what I've actually done in person. What's really going on here beyond the NFC, beyond the in-person event, is I'm taking my history of interactions in the real world and I'm digitizing it. Verifiability. Every single thing that I've done at the event is now a signature. Every single thing is something that I own and I possess, that I can prove to someone else. And so now this data that I've collected about myself is more meaningful. Okay, so 3 things that you could actually concretely do with these signatures in the app. And you'll be able to test some of these things out. First off is generating ZK proofs. And so this is where we care about privacy. So if you want to keep your interaction history private, this is where zero knowledge proofs come in. So one example here is that you could prove that you attended 5 talks. And the ZK part of this is that you could prove you attended 5 talks without actually revealing which talks you attended. So the actual talks are kept private. That's where the zero knowledge step comes in. But at the same time, you could still, hey, get this proof that says, oh, I actually did go to 5 talks. I was engaged at this conference, but I still kept my data private. Next up is private set intersection. So let's say I just met Callie at the event and we didn't know each other, but I kind of wanted to get to know him a little bit better. One way to do this is by seeing, hey, what people have we met in common? What talks have we both gone to? And this was a little icebreaker that allowed you to get to know other people at the event. The way this would work is you have your list of signatures, which represents a bunch of talks you've been to, represents a bunch of people you met. Callie has his list of talks and speakers, or talks and people he met, and we would compute the overlap. So I would be able to figure out, hey, what people have we met in common, and what talks have we both gone to? And this is something that we would be able to do without actually sharing everything else. The only thing I would learn about Callie is the people that we had in common, that we met in common, and also the talks we went to in common. Every other piece of data remained private. And so this was done using a combination of 2-party computation and fully homomorphic encryption. So a little bit of advanced cryptography, but if you're interested in that kind of stuff, we can chat more about it later. Finally, folding schemes. This was a little fun experiment where we wanted to create an experience that was like Spotify Wrapped. If any of you have used Spotify Wrapped before, it basically summarizes your listening history at the end of the year, and it says, hey, these were your favorite songs, these were your top artists, and it just kind of wraps up your listening experience. We wanted to do something similar for the conference, and so you would generate a single folding proof using folding schemes to be able to say, hey, I went to X number of talks, I met this number of attendees, I met this number of speakers, and all this would be wrapped up in one ZK proof that you could send out in public. Okay, cool. Final thing here is a bonus little experiment we did at Denver with email NFTs. So this was in collaboration with the ZK email team, so shout out to them. The idea here is that you want to get an NFT, get some sort of on-chain commemoration that yes, you actually did check into a specific location or you did do a specific thing. And so when you checked into a location at Denver, you would get a signature, and this signature represents your proof that you actually went to that location, and then you could use this proof to redeem an NFT that would go straight to your email. And the nice thing about using ZK email for this is all these NFTs just only work with your email, so you don't need to really interact with the wallet at all. It just gets sent to your email, and you can interact with this NFT, play with this NFT within your email. So very good experience there. Cool. So that's a little bit about the experiences that we've done in the past and the sort of activations that we've done with NFC and with signatures. But there's a broader goal here, and the broader goal is to take any sort of personal data and make it user-owned and make it verifiable. And so something that we're looking into now is exploring different types of signed data. There's data from emails, which can be verified with ZK email. There's data from HTTPS or any sort of authenticated API that you might use. For example, you could go to Uber or Lyft or something like that, and you could get your rating out of it. So this is using TLS Notary and other technologies. There's also documents. DocuSign signs some documents with certain signatures. That's something we might play around with. But the crux of this is that this cryptography allows you to actually own your data. It allows you to take your data from these different silos, and it allows you to take control of it. And because you have the signatures, you can prove that this data is actually verifiable, it's authentic, and you got it from a trusted place. But at the same time, now owning this data actually makes it yours, and you get to decide how to use it. Cool. So finally, a little bit more about Cursive. We're building applications of signed data and advanced cryptography. If you're interested more about like these topics and like what we want to do in the future, feel free to talk to me, Callie, Rachel, or Vivek. Here's also some links, Telegram, and a website if you're interested in chatting with us. Shout out to Privacy and Scaling Explorations for supporting this project and supporting the team. And finally, we have a little bit of a demo. So instead of using NFC cards, as we did at ZK Summit, Vivek got these beautiful like NFC rings that every single resident at the residency has. And these NFC rings give signatures from tapping them. And so what you can do is you can scan this QR code if you're not a resident, and you can quickly sign up. And this is really easy. You're just signing up using passkeys. And now you can go around and tap other residents to get signatures from them. And so this is just a little like hands-on demo, being able to try out what this experience actually feels like. And so for the first X number of people who like prove you met 10 people at the residency by tapping their signatures, you can make a zero knowledge proof about it, and we'll give you a ring and you can take it home and play with it. Cool. Any questions? Yep.
So many NFC projects I've seen are primarily using NDEF records, and so they're kind of just the same as a QR code, but you're indeed doing signatures here?
So there's three sort of levels that we've played around with. And these levels like have different trade-offs. Certain levels like these NTAG 212 chips, they can just give static data. So they can give like a static URL, there's no cryptography at all, nothing there. But the upshot is that it's very fast. And so a lot of hotel cards are like this, where this is why they're easily hackable. They just give static data, and you can go like sort of play around with it and like change that data, and it's pretty malleable. So that's like one side of the spectrum. The other side is the activation we did at DevConnect was using JCOP4s. So these cards actually generate signatures on the cards themselves. And the advantage of this is these cards actually are also Ethereum accounts. Like the cards themselves are accounts because they hold private keys. And the cards are secured by the same technology that secures your credit cards. And so they have these like secure elements that do like secure cryptographic processing. And so this is like extremely trustworthy. And this is like the other end of the spectrum. But the downside of these is that the tap experience is a little worse. You sort of have to like tap and hold your phone for like 2 seconds on these cards. It takes a while to get a signature because it's just generating this over a bit of time. It's got limited power. And so the in-between for that is what we did for ETH Denver. This is using NTAG 424s. And in this case, you're doing a little like lighter weight operation. The card is generating a CMAC, and this CMAC gets authenticated with the server. And then once the server verifies that yes, this tap is legitimate, then the server issues a signature. And so that's kind of like an in-between point where it's still pretty fast, but like you lose a little bit of like the pure card generating signature part.
What was the device you mentioned that was all the way on the left?
JCOP4s. JCOP4. And then we're also like looking into SLJ52s. 52? Yeah, SLJ52s is another like supposedly like does the same thing, generates signatures on the cards, but they're supposed to be much faster. So that's something that's coming soon. Anything else? Cool. Zora?
Yes, thank you. I think you use FHE for PSI, but as far as I know, there are also many other ways to achieve the PSI without FHE. So what is the reason to use FHE? What is the reason that you implemented PSI using FHE and not with other schemes?
You can give your take on this. My answer is like experimenting with FHE mostly. The nice, like, part of it is we want to play around and test the technology. The nice thing about FHE is like, maybe we can get to a position where like this can be non-interactive, right? Like if you have a bunch of data from different places and you want to maybe be able to like make queries on that data or learn about that data in a non-interactive way, then we want to be able to get FHE to that point. But I don't know. Do you think like if we just did pure MPC, it could have been like more efficient for PSI stuff?
Yeah, I think the main reason is just like we could do a custom build for PSI. Like there's lots of really great libraries that exist, but there's I think more long-term potential with deepening our explorations into FHE. We can just do more expressive computations than just a PSI. So that's the main reason. I think probably efficiency-wise, there's like a really good Microsoft library that does PSI stuff that probably would have been faster and maybe even easier to implement, but yeah, more for longer.
I just thank you for asking this.
Anything else? Great, why don't we start tapping rings then? If all of you are signed up, then you can turn around to some resident next to you. Okay, how about if you're a resident, raise your hand here in the audience. Okay, so if you're a non-resident, turn to a resident and start tapping their rings. Let's go.
Thank you, Andrew. So, for the rest of the evening, 7:21, we got like about 45 minutes. We have the space until 8, so we'll set up 3 different stations for the teams that have presented so far. Let's do like, we can do like proof of passport at this table, MynaWallet near this area, and Cursive will be by that table where Rachel and Florent are sitting next to. Do you want to wave? Right there. So we'll be posted up by those places, but also feel free to talk to other teams. For other resident teams, if you could kind of gather with other people you work with so you could kind of answer questions together, that would be very good. But yeah, thanks so much for attending. And yeah, let us know if you have any questions. Thanks. Yeah, that's it. So you guys.
Did you join this experience? Did you sign up for this? If you want to try it.
Now,
That's
you
kind
want
of
to tell them that
Just
try to find it. Yes, exactly. And then you see how
Hi guys, one more announcement. We have pizza coming. There'll be food arriving shortly, so feel free to hang out for a little bit and take as much as you want. That's all.
However, do you want to get your sticker? Here. Thank you. So for your phone, what was I gonna do? I was gonna do a thing. I was gonna get him a sticker.
yes, you can link it. If it's, you'll have, he'll get you a sticker. And then that will be your profile. And then once we each have like this, discover all this and then show
It's just fun, right? It's not very easy, but it's fun. Like I'm not into it's just fun to have.
I literally tested all the QR codes. I'm like, there's no way.
Yeah.
Yeah, so that's me. And then L for one. And then
Spotify media, the number of
yes.
Hey, were you did a lot?
Oh yeah. Yes. It's very already registered. Oh, yes. Oh, okay. Yeah. Oh, he wants it. Might ask Vivek. He'll give you a secret. He wants he wants to buy it. He wants to buy it. He wants to buy it.
That's I mean,
Thank you.
And they said like, but this is
Yeah, I saw that. I was like, maybe you think it's very strong.
没有什么问题吧？对，但你要回去研究一下。
Yes. That's what's silly.
How do you like the business?
This one.
Yeah, okay. Very nice. Thank you.